The other thing is about theoretical yield, actual yield, and percent yield. When we come to the term theoretical yield is the measured amount of, it's the calculated amount of product that is produced during the chemical reaction. The theoretical yield is calculated using the limiting reactant, which is a reactant that it's completely consumed first before the excess reactant, and the actual yield is what is the measured amount of the product after the chemical reaction proceeds. And usually the actual yield is less than the theoretical yield, but it has never been equal to the theoretical. It actually has never been equal to the theoretical yield because there is no efficient chemical reaction in this whole world. There is no percent yield of 100% in this world. And when we, if the actual yield is greater than the theoretical yield, then the reaction that is proceeding may be a competitive reaction. A competitive reaction is a reaction where the product is produced, competes to combine with one of the reactants and produce more products. In this case, the actual yield will be greater because more products are produced, but this is impossible. Our percent yield will be greater than 100%, and that's kind of impossible. Here we can see that, for example, to understand what's limiting an excess reactant and a theoretical yield mean, we've got 5 hot dogs here, but we've got 4 buns here. So, which one's the limiting reactant? The buns, because they are 4 in number. Here they are excess. There's excess amount of hot dog here because there are only 4 buns. 1 hot dog for 1 bun. So when we combine the hot dog with the bun, we get 4 hot dogs in a bun. But one of the hot dog is left, which is an excess reactant. So the excess reactant is the one that is found in excessive amount, more than the necessary amount, and we can use the completely consumed amount of excess reactant to calculate the theoretical yield. And lastly, we have the topic solution. We've learned this recently, and the solution is the mixture of, or the homogeneous mixture of solvent and solutes. We all know that homogeneous mixture is a mixture that has only one phase and there is no visible boundary. And a homogeneous mixture that is made up of solute and solvent is called a solution. It's a special type of homogeneous mixture. And in a solution, the solvent is found in a larger amount, so it's called the major component of the solution. A solute is found in lesser amount, which is called the minor component of the solution. And there are different characteristics of a solution. First is that a solution has its particles are very small. Their size is about the size of individual particles, atoms, molecules, or ions. So they can easily pass through a filter paper. This causes the solution to not be separated using filtration. It can only be separated using evaporation and distillation, but we can't use filtration. And there are different types of solutions. These are based on the physical state of solvent, because the physical state of solvent determines the physical state of the solution. And when we look at the 3 types of solutions, these are gaseous solution, liquid solution, and solid solution. Gaseous solution contains a gas solute and a gas solvent. It cannot, the solute cannot be liquid or solid because liquid and solid have much higher density than gases. So they may take the place of the gas, which means they may become the larger component, or they may have large amounts in the solution. So in a gaseous solution, both solvent and solutes are always gases. For example, our atmosphere. Our atmosphere is the mixture of different kinds of gases, such as nitrogen, oxygen, methane, and etc. So if we want to know the solvent of the atmosphere, we look at one of the gas, which is found in larger amount, which is nitrogen, which composes around 78% the atmosphere. And when we come to the liquid solution has a liquid acid solvent. So the solute physical state may be solid, gas, or liquid, but the solvent must be liquid. As we look at this, this is a liquid solution because the solvent is liquid while the solute is solid. Example of this is salt solution, which contains salt and water. Water is the solvent, while salt is the solute. And the mean or the physical state of the solution, as I stated, is determined from the solvent. So the solution of salt and water gives us salt solution, which is water, which is liquid in its physical state. And last but not the least is solid solution. Solid solution contains both solids and solvents may be solids. Maybe solids can be three of the physical states, but solvent has to be a solid. For example, hydrogen and palladium. The hydrogen is the solid, which is a gas, while palladium is a solid, which is the solvent. And we have dental filling, which is composed of silver and mercury. Mercury is in a liquid state, while silver is solid, which is the solvent. And the other thing, there, for example, are alloys, which are